All right, hello everyone. I'm trusting that you can see and hear me now. Can you just click or type you can hear me? That would be really wonderful. Thank you. All right, so today we are going to be looking at solving exponential and with you too. But let's just start at looking at some of the basic questions. Fantastic. Thank you, Tyler. Thank you, Ben. Okay, perfect. Or Taylor, sorry. Hi, Zetong. All right, so solving logs and exponentials, very, very standard maths that we need to do. We're going to start with some pretty easy questions because I think it's really important that we recall where we're from, what we're doing. Fantastic. So, let's look at something. X equals 2 to the 3. Whoa, what's x equal to? X is equal to 8. Okay, that's not really a question. It's what is 2 to the 3? Not a bad question, but not an easy question. Hello, guys. Nice to see you here. Okay, well, my next question. Okay, that was not too hard. My next question is well, how about. Okay, so this question, well, how do you find x? And so my question now is this one here. What is x? Okay. And this question is pretty obvious that x is 3. But my question is calculator. Here we had to do the cube root, the opposite of the power. And now in this kind of situation, how does an equation go from that to that? And that's where we're going to start today, because that's really important. Are we all with me? Can you hear? Do you understand what I'm trying to say? Okay, just comment in the conversation periodically saying, "Yep, we understand," so that it's sort of like nodding, because otherwise I could just be talking to myself, and that's not going to be fun. I mean, quarantine's done things to me, but I don't want to be talking to myself whilst recording, because that's insane. All right, so I'm going to say we're going to look at logarithms. Okay. So logarithms are really important because they are how this goes from this to this. Okay. And I'm going to introduce a few log rules, but I'm going to just quickly outline the ones I want to talk about. So these are the log rules. The first one is log of A. So what log is, we'll figure out soon. Plus log of B, it's just like a basic rule, okay, is equal to log of A times B. And you're like, Mr. Dharma, when will we ever see something like that? Well, let's have a quick look at something like this. X squared times x cubed. What's the power? It's not x is 6, it's x5, right? So we've been used to seeing things that when you add them, it becomes a multiply. But that's the opposite of what's happening here. When you multiply them, they add. And so it's a kind of opposite thing that's happening. And so it's not too dissimilar, but just think about it like that, right? Okay, now let's look at another log rule. And this is from manipulation. And we don't actually need these ones, but I just wanted to remind you of them. Log A minus log B, right, is log A divided by B. And once again, this kind of awkward thing happens when we do division. If I do the division here, it is log, oh, crumbs, it is x to the power of 4, which is 7 minus 3. And so you see that kind of thing happen before, but the opposite way. And then the third and most important log rule is if you have log of a to the power of b, it is equal to b log a. And I call this the blogger rule because it's b log a. So I'm going to refer to this as the blogger rule from now on, okay? And you want an example for this? You can't have an example for this just yet. I'll get to it soon. But these are 3 log rules that are really important to us. And you're like, what is a log? No one really knows. We'll get there, okay? So let's try something interesting. Let's go back to this. 2 to the x equals 3. Okay. What I'm going to do is I'm going to take the logarithm of both sides. So I'm going to say log 2 to the x log 3. Okay, this is an operation now. Okay, forget about all of that, but this is an operation. I can log both sides. Okay, and then what I can do is I can take this power x using the blogger rule and I can move it to the front. And so now we have x log 2. I'm still not sure what logs are yet, but I'm trusting that you guys did some in manipulation. Okay, I've moved the x to the front, and now to get x by itself, I'm going to go divide both sides by log 2. So log 3 divided by log 2. Ooh. Sorry guys, let me just fix that up. That was meant to be an 8 the whole way through. Okay, log 8 divided by log 2 gives me x equals 3. And what I want you to do, I want you to grab your calculator, type in log 8 divided by log 2, using brackets really carefully, and you should get 3. And then we'll have a discussion as to what that is. Have you typed it in your calculator? Is that what you get? If so, what is a log? It works, it's magical, but it shouldn't be. Now, here is a log. Log base 10 of 100. What does that even mean? And I want to read it like this. What is the power of 10 that gives 100? What is the power of 10 that gives you 100? And the power of 10 that gives you 100 is 2. Okay, and that's all logs are. Logs are ways of asking for the power. Okay, and so in fact, when I do this, log 8 divided by log 2, it is another way of writing what is the log 8 divided by log 2 is another way of writing what is the power of 2 that gives you 8. And so, of course, our answer is 3. And so this and this are the same thing. So whether you write log 8 divided by log 2, or you write log base 2 of 8, it's the same thing, the same idea. You're asking, what is the power of 2 that gives you 8? and that's 3. And that's how logs work here, okay? Interesting notation, but this is how you get the algebra from there to there, and that's what we had us concerned with before. Okay, I'm going to give you a few questions to do now, and once you've done that, then we're going to continue, okay? Try these. Okay, question 1. What is the power of 3 that gives you 9? Try to do the algebra for it, okay? Question 2. What is the power of 27 that gives you 3? And question 3. What is the power of 16 that gives you 2? Okay, these 3 questions, I'm going to leave them there for about 30 seconds, and then I'm going to let you have a go. Knowing that this log function allows us to do some pretty cool stuff on our calculator. And these ones are all fairly nice. You could probably work out the powers using your head. Okay. I'm going to give you another 15 seconds. Yeah, okay, cool. So I'm hoping you've given it a go, but let's see what I do. I'm going to write log on both sides, because this is an operator. And then I'm going to use the logger rule to bring the x to the front. And so then I have x log 3 log 9. And then I'm going to divide both sides by log 3. And so I'm asking once again, what is the power of 3 that gives me 9? And the power of 3 that gives me 9, if you type this into your calculator, it will give you 2. Similarly, I'm going to do the same for this question. I'm going to log on both sides. This time I picked a number bigger on the left-hand side and a smaller on the right-hand side to show you it doesn't matter. I'm going to use the blogger rule to move the x to the front. And then I'm going to divide both sides by log 27. And you can sort of tell that it's going to be a fraction now because the bottom's bigger than the top. Okay? But once again, what is the power of 27 that gives you 3? Well, if you type this into your calculator, you will get a decimal, but a fraction is 1/3. Because 27 to the power of 1/3 gives you 3. Okay, and then the last one, I'm going to do exactly the same. 16 to the power of x, log 2. I'm going to bring the power forward using the blogger rule, and then, oh, that's the wrong color. X log 16 equals 2, log 2 rather, and then I divide through by log 16. And once again, if I type this into my calculator, it should give me 1/4. And that is how you solve exponentials. Pretty standard. And they're all fairly nice numbers. And you could probably do this without going through the algebra because you should know that 3 to the power of 2 gives you 9. 27 to the power of 1/3 gives you 3. And 16 to the power of 1/4 gives you 2. But hey, this is how you do the algebra to make x the subject. And that's what I'm looking at. What is the algebra that makes x the subject? I'm going to just drink some water. Now, what I'm going to do is I'm going to ask you the same questions, but I'm going to just change the numbers on the end. And I'm going to ask you, should the maths become any harder? Okay? And I want you to think about it. All right? Okay? I'm going to just put these questions up. Question 4. And so this is 3x, 3 to the x is equal to 10 now. Okay, question 5. 27 to the x is equal to 4. And question 6. 16 to the x is equal to 3. Okay, I've just changed the numbers a little bit. But should that change my maths? Should that change my maths so much so that I can't do these questions anymore? Because before I could do them in my head, and now I can't. The reason being is because now they're not familiar numbers. But the algebra should still stay the same. My answer for this one should just be above 2. My answer for this one should be above a third, and my answer for this one should be above a quarter. Can you try these out and see if you do get them? Okay, random thing to do. Type in the word pizza to tell me you're listening. I miss pizza, guys. Let's be honest. Thanks, John. Pepperoni pizza. How about that then? All right. Okay, let's try these and see what we do. Okay, fantastic. Plenty of people writing pizza. This is fantastic. Okay, here goes. All right. So, first thing to do, I will log on both sides. Then I'll use the blogger rule to bring the x to the front. And some of you might be thinking, Mr. Dharma, this is so easy. Why are you doing more questions? And my answer is, just you wait. All right, now I'm going to divide through by log 3. And once again, you type this into your calculator. And I don't really normally have a calculator with me. So I'm going to trust that you guys know the answer. But I will really quickly check anyway. I think it's just over 2, so I'm going to write about 2.096 3dp. I think that's correct, give or take. Okay, let's try this one. I'm going to put a log in the front, and then I'm going to use a purple, use the blogger rule to bring the x to the front. X log 27 is equal to log 4, and then divide by log 27, and then type that into your calculator once again. Use brackets, guys, otherwise bad things happen to good people, and I don't want that happening to you, especially when I can't come and check your calculator because we're all in quarantine. And this is 3dp. And the last one, because I feel we should do something more exciting. This is pretty boring now. Like, the maths is pretty easy now, isn't it? If you agree, say you do, that you're finding. Oop, whoa, what did I do, man? Okay, let me just zoom back in, team. Sorry, technical difficulties. Alright, what do we got? X log 16 equals log 3, and then we divide by log 16. And then, if we type that into our calculator, hopefully I get something that's just above a quarter. Alright, and so for me that one is 0.3962. Oh, I keep writing 3dp. In this one, it was actually 4dp. I'm just going to change my answer to that. And this one, I'm going to change my answer to that. Alright. Okay. Do we have to put it in decimal? Monique, yes, we should put it in decimal primarily because these ones are really ugly and they don't actually look pretty. And Kenny, can you explain to me, like, okay, which question would you like me to look at again? I'm not sure what we're not comfortable with. I sort of want us to realize that once we put a log at the front of these, it lets us bring the power to the front. And once we've brought the power to the front, we can just divide by log. Doesn't really matter what log is. Don't worry about the thing, but we're asking what is the power of 3 that gives you 10, and we can just use our calculator in this fashion to get the answer. But algebraically, if we want to make x a subject, we have to use this thing called logarithms. Okay. Now, for those of you who have found this tricky so far, please, please, please look back at these questions. I'm going to say that these questions can be found in your workbook on page 27. So, of your algebra workbook. If you don't have your algebra workbook, ask your teacher for Education Perfect. When you say use brackets, do you mean like that? Yes, exactly, Matthias. That's how I mean. Because if you put it in your calculator and you forget the brackets, sometimes it does some dodgy things. So yes, exactly. Put it in like that and it should work. So page 27 and yeah, 27 is where this kind of stuff can be found in your work. 12. Okay, once again, we're solving for x. Okay, page 27 and 20. Okay, you notice that I've just changed the power. Okay, but the steps should still be the same. All right, so I'm going to put a log at the front. Move the power. This time the power is x plus 1. And I'm going to put that in brackets here. And so the power is now x plus 1. And now I divide. And now to get x by itself, I have to subtract 1. And so now you can see the algebra is creeping in. And so if you type that into your calculator, using brackets very carefully, you should get an answer that's pretty sensible. So try that. Brackets log 12, close brackets, divided by log 3, close brackets, subtract 1. And for me, I get 1.262 3dp. And I don't know, I feel that that was not that much of a step. I'm going to put up a few more questions for you, and I'm going to see how you go. Okay. I'm going to call this question 7, and this is going to be 4 to the x plus 3 equals 17. Question 8 is 3 to the 2x plus 1 is equal to 7. And then we will have question 9, which is 27 to the power of 2x plus 3 is equal to 4. And then question 10 will be something really interesting. 0.7 to the power of 2x is equal to 7. Okay, that last one's a little gnarly because the number's going to be a bit weird. But give it a go. Yes, Ben, you can have Education Perfect. It'll be posted to your Google Classroom. But just check with your teacher. I am your teacher, Ben, but I'll put it up soon. Right. Give these questions a go. See how you go. Remember, the linear algebra that we did from yesterday is really important. You need to be able to manipulate linear equations if you want to do algebra. Kenny, how badly are you lagging? Everyone's probably lagging about 30 seconds from when I answer a question. But maybe skip to the end of the video and then it'll be at the right time. I'm going to give you another minute on this and then I'll solve them. And remember, this is page 27 and 28 in your book. There's plenty of questions like this for you to do. Is question 7 supposed to be negative? It might be negative, yes. Yep. Question 8. Question 8, yeah, also might be negative. That's fine. Question 8 shouldn't be negative. It should be a fraction. Question 7 should be negative. And question 9 should be negative. And question 10 should be a fraction, I think. Not a nice fraction. They're all decimals of some terrible nature. None of these questions will come out with nice numbers. And if they do, that was by accident, not because I designed it that way. Okay. I think I've given you plenty of time to have a look at these questions at least. And what I'm going to do is I'm going to start trying to solve them. How much should we round to, Monique? You should do about 3 decimal places. It doesn't matter so much. Context will apply. But later on, when you do word problems, it'll be more apparent as to how much you should round. For now, round to 3 decimal places unless you get told otherwise. Does that make sense? Okay. So I'm going to do these now. And then I've got a few interesting questions for us. Okay. Yep, okay, here goes. So, I'm going to try do this. I am going to log both sides. I'm going to move the x plus 3 to the front. But I'm going to put in brackets. It's really important to do this. And then I'm going to divide by log 4. And then I'm going to subtract 3 and then hope that this gives me the answer I want. So, brackets log 17 divided by log 4 minus 3, and you should get negative 0.956 3dp. That's question 7. That looks a bit messy, I'm sorry guys. Question 8, I'm just going to do a little bit further over, and I'm going to go log, that looks terrible, log 3 to the 2x plus 1 log 7, and then I'm going to bring the 2x plus 1 to the front now, and then I'm going to divide by log 3, and then I'm going to subtract 1 and then divide by 2. Make sure you type this into your calculator very clearly, team. It's very easy to mess these up because you've typed in silliness. Remember, if you put garbage in, you will get garbage out. Just be careful with how you type it in, and you should get 0.836, sorry, 0.386, and then this one here, log 27, 2x plus 3, log 4. I'm going to move this to the front again. Remember, the reason I can move it to the front is because of my blogger rule. Make sure you check your brackets now. And so I'm going to subtract 3 and divide by 2. And that in my calculator gives me log 4 log 27 subtract 3 divided by 2. Guys, can you please comment if you think I'm correct? If I've made a mistake, please let me know. I'm not going to do this perfectly. Remember, I'm doing this at the same rate you guys are, but I've given you a bit of time. So, okay, log 7. And then I know this one's going to be pretty interesting. And so then I divide by log. Then I divide by 2. And so then I go log 7, log 0.7, divided by log 0.7, and divide that by 2. And so your final answer is negative 2.728 to 3dp. Okay? Fantastic. Awesome stuff. Thanks, guys. That's awesome. All right. So those are log questions. You can't really get harder than that. The numbers can get bigger. So instead of using numbers like 4, 3, 7, and 27, I might use 8,000, 9,000, 400, 1,200, stuff like that where the numbers are big, because exponentials are really important. And like currently we're learning about exponentials, but we're seeing exponential growth in things like coronavirus, right? And so that, I don't know, maybe it's too soon, but exponentials numbers get real big real quick. um, and so yeah, I'm gonna try one more question, and then maybe just allow for some more questions from you guys. um, I'm going to try something pretty strange looking. Try this. Okay, and we're going to solve for x, and it's going to be an awkward number. This time I'm going to give you 4.2 times 2.7 to the power of x equals 2000. Right? What do these numbers mean? I'm not sure, but you're going to have to solve for x. I'm going to leave this up here for a bit. Maybe I'll put a time symbol in here. See if you can give this a go. I'm going to call this question 11, and then we'll do question 12 over here. We'll do one more, and we're going to call it 2.7 times 0.92 to the power of x is equal to 1.35. If you can figure out where this question's from, when we start school again, come and find me and I'll give you some chocolate. Okay. Okay, so the point is I made the numbers awkward because I wanted to see how the maths changes. And it shouldn't. All right. Okay, I'm going to give you another minute here, and then I'll try go through them again, and then you'll be able to check. And then I'll probably call it a day, unless you can ask me questions right now, like, is there any specific thing you want me to go over? And then I can continue that at the end of this stream. Otherwise, I will wrap it up after I do these two questions. So ask now. John, what's up? What are you looking at? The fact that these questions look gnarly? Yeah, the questions are pretty hard because there's going to be decimals. And it's really important that you don't round terribly. And after marking 165 trig papers, I know some of y'all need to learn how to round better. So, Ben, why are you confused? We're still just solving for x, but I've just added horrible numbers. Okay? Just try watch. Oh, Joan, you want some chocolate, eh? All right. I think I've given you almost a minute. Bye, Kenny. Don't think I know who Kenny is. Oh well. Anyway, so let's try solve this. First off, before I can deal with the x and log, there's this number at the front. I'm going to divide first. And so I get 2.7 to the power of x, then 2000 divided by 2.4. Now it's the kind of question I have. This 2000 divided by 4.2 looks a bit ugly. Yeah, Ben, that's fine. Like, you look at it and you go, nope, but that's because that's how things work sometimes. They're a bit scary. And Kenny, the next stream is 4:30 tomorrow. So once I've got that, I could try to type that into my calculator and get a decimal version of this, but I don't really want a decimal version of that. So I'm going to just try to leave it like that. And then I'm going to try log both sides. Once again, ooh, wrong color. Log, yep, 2.7 equals log. And just check this, I'm being very careful with my brackets because I don't like decimals and I don't want to carry any new ones. And then I get to move the x. You could type this into the calculator, but it might start giving you like rounded numbers. And when you are working with logs, the more you round, the more wrong your answer is going to be. So I don't want you to round. I'd rather you work like I am. Okay? Now I'm going to type that whole thing into my calculator. Okay? So I'm going to go open brackets, log, open brackets, 2000 divided by 4.2, close brackets, divided by log 2.7, or open brackets. And my answer is 6.208 to 3dp. I hope some of y'all got that right. And then I'm going to try this next one. So once again, where did that 2 go? I'm going to stick a 2 there. Once again, I'm going to divide by this this 2.7. So I have 0.92. And in this one, if you feel like writing this as a decimal, you probably can, because I know that 1.35 is half of 2.7, and so that part is going to be 0.5. You know? I know that. So if you do, you can use it. But I'm not going to, because I think a lot of people will be like, what? How did you do that? And so I'm just going to continue with the decimals. Right? I'm going to log both sides, and then I'm going to use the blogger rule, bring the x to the front. And I see no one's asked any new questions. So this is going to be near the end of my stream. So thanks for hanging out, guys. And can you encourage more of your friends to come along next time? Because, I mean, I am taking a lot of time and effort to make these, and it'd be really cool to see more of you here. I'm very happy with those of you who have turned up, but I'd like to see a few more people, if that's okay. Log 1.35 divided by 2.7 divided by log 0.92. And yeah, the formula is very similar, Ben, yeah. And then 3dp. Check your rounding, because some of y'all rounding is pretty off. But that's my answer. This is how you'd solve log questions. I haven't done application questions because I don't want to do application questions. But we'll do that another time. But try to practice solving these questions. These questions can be found on, once again, page 27, 28. And if you want to try page 30, 31, 32, 33, 34, there's word problems. They're a little tricky. They might work. Good luck. And tomorrow's tomorrow's live stream will be about quadratics. So make sure you pay attention, and I'll talk to you later. Thank you guys. Stay well, stay safe, and I'll talk to you later. Bye.